Hello friends, today we're going to look at the inside of an Oral-B Pulsar electric toothbrush. Now the key thing about this is it doesn't do much that an ordinary toothbrush doesn't do except that it vibrates. Put that up close to the microphone. So the question is, what makes this vibrate? We've obviously got a battery there. We've got an on-off switch. I've used these for several years. I can recommend them as just strictly as a toothbrush. They come in a 2-pack for about $10, so about $5 each. And if you pop this open, that part just unscrews. Pull this out, and a very clever mechanism. One thing I wasn't expecting the first time I took one of these apart was a Duracell OEM battery. And this little mechanism, they've got a very simple little switching mechanism here. As you can see, the vibrator is just a little tiny motor with an off-center metal mass on it, so it naturally vibrates as the mass moves around. We got this rather clever switching mechanism that's run by what appear to be 2 switches on the outside, but these are actually just rubber pieces that operate the mechanism inside. So we're going to go ahead and tear that apart. And of course, one of the fun parts of these is when the toothbrush is shot, as you see here, you get to have fun with the innards of it. So not only is this a good way to clean your teeth, you're going to have a little bit of extra fun when it's all gone. Turns out I'm having a lot of extra fun trying to get this apart. Looks like it's time to get out one of my tools of persuasion. We don't care about the switching mechanism. Throw that aside. Maybe the next time I use one of these up, we'll go into that in another video. But as you can see, this is just a little tiny motor with this weight on the end. It has 2 leads, runs directly from a standard 1.5 AAA battery that comes inside here. And these aren't really intended to be reusable or replaceable. But it turns out if you can buy other ones that have a detachable head where you just replace the head, which makes sense except for the fact that on the replaceable ones it kind of amounts to, give you the razor and sell you the blades, which is the heads are pretty expensive and the bodies are not that expensive, so you end up spending more. And that's kind of why I like these. And if you lose them or throw them away or whatever, it's okay. And like I said, here's your toy surprise when you are a good boy and brush your teeth. Here's another view of it from on top. See if we can get this thing to focus up close. Focus, Luke. The focus will be with you. Here's a shot of a little test setup that I've put together. We're going to use this power supply to run our electric toothbrush motor at different voltages, which is going to turn into different speeds since this is a DC motor. And we're going to see what happens when we put in way more than it's supposed to have. So here goes. So this is nominal operation, which is 1.5 volts, and looks like the thing vibrated itself to become unconnected, or disconnected as we say in the business. Well, here's the problem. The vibration of the motor broke off the lead on the motor itself. These are some very tiny wires that really aren't designed for use outside the toothbrush. See how small that is. Let's take a closer look at the motor while we're here. So it turns out the best I can do with this wire broken off is just hold this on here directly. I'm at 1.5 volts. We're going to turn that up a little bit. Let's go to 3 volts just as an experiment. I've set the power supply for 3 volts. It runs faster. Let's keep going in increments of 2 or try 6 volts. This goes faster. You can really feel it kick when it starts up. Here's 12 volts. The motor's getting very warm, so that's a sign that I'm running it beyond its limits, which I knew, of course. So having run this on 24 volts, I find that it still works. It's gotten very hot. I only run it for short times, mainly because I had trouble contacting the little tiny stub of a wire that's left here. But it does work, and kind of what we'd expect to happen if we kept going would be the thing would burn itself out at some point. But as with all DC motors, the more voltage you put into it, the faster it goes, with all else being equal. We'll find a purpose for this motor in another installment, so stay tuned for that. Thanks for watching, and bye-bye.